Hey guys, this looks like a fun one. We're given a square and a circle, and it looks like they touch here, here, and their tangent right here. We're given that this distance is equal to 1, and it wants us to find the area of the square. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, let's label the side of the square S. So the area of the square will be equal to S squared. This is what we're trying to solve. Let's put a box around it and move it down here. Next, let's mark the center of the circle and let's draw this radius. And let's label it little r. The diameter of this circle will equal 2 little r. But the diameter is also equal to something else. The base of the square is equal to S, and that's the same as this distance right here. The diameter of the circle is also equal to S plus 1. Both of these are equal to the diameter of the same circle, so we can set them equal to each other. 2 little r will equal S plus 1. This looks important. Let's put a box around it. I don't think we need any of this anymore, and let's bring this up here. Next, let's focus on this right triangle right here. The base of the right triangle, this green portion, it will be equal to the radius minus 1. So we'll call it little r minus 1. And then this purple height of the triangle, that is equal to half of a side length of the square, or in other words, S over 2. And now in this right triangle, we can do the Pythagorean theorem. It'll be little r minus 1 squared plus S over 2 squared equals little r squared. And then from here, we can clean things up. Little r minus 1 squared is equal to little r squared minus 2 little r plus 1. And then for the S over 2 squared, the square will go to both the top and the bottom, leaving us with S squared over 4. And then on the right-hand side, we can bring down the little r squared. Both sides have a little r squared, so let's subtract little r squared from both sides. On the left-hand side, these will cancel each other out, and on the right-hand side, these will cancel each other out, leaving us with 0. And then for the next step, inside of this box in this equation, the 2 little r is alone. Let's do the same thing down here. Let's get the 2 little r alone. We can add 2 little r to both sides of the equation. On the left-hand side, these will cancel each other out. And on the right-hand side, we'll have 2 little r. And now we have two equations set equal to 2 little r. Since each of these are equal to 2 little r, let's set them equal to each other. S plus 1 equals 1 plus S squared over 4. Well, first let's subtract 1 from both sides. So all of this on both sides will cancel out. And we're left with S is equal to S squared over 4. I don't really like fractions, so let's get rid of this 4 in the denominator. We can multiply both sides by 4. And that'll leave us with 4S is equal to S squared. Now let's set everything equal to 0. We can subtract 4s from both sides. On the left-hand side, we'll have 0, and on the right-hand side, we'll have s squared minus 4s. Each of these terms contains an s, so let's factor out that s. After we factor an s out of this, the s squared minus 4s will become s minus 4. So now we have 0 is equal to s times s minus 4. Anytime you have something times something equal to 0, it'll be true if either of those somethings is equal to 0. So how do we feel about s equals 0? S is equal to the side length of our square, so this is not possible. And then for the s minus 4 equals 0, let's add 4 to both sides, and we end up with s is equal to positive 4. And this is a valid solution. In the place of the s of the area formula, let's plug in 4. And 4 squared is equal to 16. Let's move it up here, give it a label of square units, and put a box around it. In the given diagram, the area of the square is equal to 16 square units. How exciting.